Hello everyone, my name is YongbinCho, and for homework 5, I built image processing app using C++ and Qt and OpenCV. So you can open an image, apply techniques from our lectures, and the program always shows the original on the left and the processed result on the right, like window on screen. The next few minutes, I'll cover what it does, the main design choices behind it, and the functions I implemented, and a short before and after demo. So at a high level, the software does five things. It loads any photo or image file. It applies operations as a sequential pipeline, so each new operation builds on a previous result instead of starting over. Each operation is button, and the parametric ones open a dialog with sliders and a live preview. I can undo or reset it anytime. It always displays the original next to the current result, and it saves the final image to a new file. The right one is the one of those live preview dialogs. Here, can you edge detection with its two threshold or sliders. I want to highlight four design decisions because they are the heart of the project. First, the processing pipeline. Every operation transforms the current image, so effects, compose, and an undo stack plus reset make it safe to experiment. Second, I separated the algorithms from the user interface. Every operation is a pure function and takes an image and returns an image, with no interface code inside it. That keeps the code clean and importantly testable. Third, the parameter-heavy operations open a dialog with sliders and a live preview, so you see the effect before you commit it. And fourth, it's a native Qt6 interface on top of C++ and OpenCV, and the single CMake builds run without any changes on Windows, Mac, or Linux. So here is how the pieces fit together. Across the top is the data flow. You open an image, each operation updates the current image and pushes the previous version onto the undo stack. You compare the original versus processed, and finally you save. Underneath are two layers of code, the Qt GUI layer, main C++, and main Windows C++. Handles the window, the menu, and toolbar, the panel of operation buttons, the slider dialogs, and the display. The algorithm layer processing C++ holds about 30 pure functions with no interface code. The key point is that the arrow only goes one way. The GUI calls the algorithm, never the reverse, which is exactly why I can test the algorithm automatically without a screen. This table is the full catalog of what is implemented. 10 families of operations, every one of them from techniques we covered in class. Color and point operations, contrast enhancement, 4 smoothing filters, 2 sharpening methods, 3 edge detectors, frequency domain filtering without DFT, 3 binarization methods, the 4 morphology operations, HSV color detection, and geometric transform without uh, forms with interpolation modes. The thumbnails are a quick preview. Let me show a view properly. The first family improves tone, contrast, and detail. CLA boosts local contrast without washing out bright areas. You can see extra texture appear in the fruit. Gamma correction below 1 brightens the midtones, and the unsharp mask increases sharpness by adding back the high-frequency detail. Histogram equalization, brightness, and contrast, and a negative are also included. For color images, I equalize only the brightness channel, so the colors may stay natural. Next, smoothing and noise reduction. The input here has heavily salt and pepper noise. The median filter removes almost all of it because it replaces each pixel with the median of its neighbors, which draws out the extreme values. The bilateral filter is the interesting one. It smooths flat regions but keeps edges sharp. Gaussian and box blur also available. The Gaussian blur has a live slider for corner size and sigma. Edge detection finds boundaries. Solver computes the image gradient, and I combine the horizontal and vertical parts into a single magnitude image. Kenny goes further and produces clean, thin, connected edges. I put its 2 threshold on a live slider so you can tune the sensitivity. A Laplacian edge map is also there. All of those run on grayscale version of whatever image is current. This family works in the frequency domain using two-dimensional DFT, connecting the spatial filtering from earlier weeks to the transform material. First, I show the log magnitude spectrum shifted so the DC term sits on the center. The bright cross tells us there is strong horizontal or vertical structure. Then I built a Gaussian filter directly in the frequency domain. A low-pass version blurs the image, and a high-pass version keeps only the edges. For color images, I filter each channel so the result stays color. Once an image is binarized, morphology cleans it up. Otis method picks the threshold automatically from its histogram, tuning the shapes into clean mask. Opening an erosion followed by a dilation removes the small specks I added on purpose, while closing fills small holes. Global thresholding with live slider, adaptive thresholding for uneven lighting, and erosion and dilation on their own are all included too. The last analysis family detects a color. I convert to HSV because hue separates the actual color from brightness and shadow much better than RGB does. Then I threshold a hue range and clean the mask. Here I selected a warm orange and red range, so the orange and the tomato are kept out, everything else turns black. In the app, all 6 HSV bounds are on live sliders. The final operation are geometric. Rotation uses an affine transform around the image center. Flipping mirrors the image, and resizing exposes all 5 OpenCV interpolation modes: nearest, linear, cubic, area, and length zones, which is a nice way to see the quality versus speed trade-off for interpolation. This is the headline feature of an action, a sequential pipeline starting from the original photo. I apply Clahet for local contrast, then a bilateral filter to clean it while keeping edges, then an unsharp mask to sharpen, and finally smart brightness lift. The important thing is that each step is applied to a result of previous one, not the original. And at any moment, undo picks back the last step. Reset returns to the start, and save writes the final image. The line at the bottom is the sequence of buttons to reproduce this. Building is simple, and the same source works on Windows and Mac. Actually, I didn't test it on Mac, but it will. In Visual Studio 2022, I just opened the project folder. It reads the CMake presets, set the Qt and OpenCV paths, and choose release and build. The May same the very same CMake list also builds on macOS and Linux. To run it on another computer, I use Qt's deploy tools. While Win deploy Qt on Windows bundle, the Qt library is next to the executable, and May's deploy Qt on macOS builds on app bundle or DMG. The one on OpenCV DLL sits next to program as well. For controls, the menu and toolbar have open, save as, undo, and reset. You click on operation in the left panel, and the parametric ones open a dialog with slider and live preview, where OK applies the cancel discards. Sample image ship with the app. To wrap up, the project meets every requirement. It is written in C++ and OpenCV and runs unmodified on Windows. It loads processed and saved images and implements about 30 functions across 10 lecture topics. It supports a true multi-step pipeline with undo and separated from the interface and verified on automated self-test. So thank you for listening, and I'll show you how actually this runs. So this is the new file, so you can change the size, and you can move these operations. And if you add this file and add grayscale, and you can see this change. And if you rotate a little bit and resize, and you can see that this change, and you can see the edge.
You can help with this. First,
You can see the edge detection and blur works fine. Yeah. So thank you for listening.